topic right? All right, so good afternoon again to everyone. Welcome to another episode of Moyo Math. This afternoon we'll be looking at Algebra Part 1. So we have about 2 to 3 weeks of algebra. We know algebra is such a huge component, and it comprises of a number of topics, and we want to ensure that we can begin the process starting with Algebra Part 1. And with Algebra Part 1, the topics we will be looking at today, questions in relation to these topics, will be simplification, substitution of numbers for variables in an algebraic expression, binary operations, factorization, simplification and factorization combined, equations, simplification and equations combined, inequations or inequalities, transposition, simultaneous equations, variation, and indices. So we will be looking at questions in relation to those topics. So let's get into it. So we started with simplification. So they want us to expand and simplify the following algebraic expressions. So we have to keep in mind we only simplify expressions, algebraic expressions. We solve equations, but we simplify algebraic expressions. So this is an algebraic expression we have to simplify. So we have 2x and in brackets x plus 5, subtract 3 and in brackets x subtract 4. So for us to expand and simplify, we have to remove the brackets. So 2x multiplied by x will give us 2x squared. 2x by positive 5 will be positive 10x. We go to multiply negative 3 by x will give us negative 3x. And negative 3 by negative 4 will be plus 12. So we have expanded. So what we want to do is to simplify. So we're going to simplify by ensuring our like terms are grouped. We already have our like terms grouped. So we can simplify. This will be 2x squared plus, we know 10x subtract 3x will be 7x plus 12. And that will be the result for the first. We can't do anything further here because all three terms are not like terms. Let's look at another expression where we are asked to expand and simplify. So we have here, and these are called binomials. So this is a binomial. A binomial is an expression enclosed within curved brackets. So this is one binomial multiplied by another binomial, 3x subtract 4. It's an algebraic expression enclosed within curved brackets. And we're multiplying those two binomials. We're going to expand by multiplying. So I'm going to multiply the first term in my first binomial by each term in the second binomial. So I'm going to multiply 2x by 3x to give me 6x squared. And I'm going to multiply 2x by negative 4, which is negative 8x. And I'm going to multiply positive 5, which is my second term in the first binomial, by each term in the second. So positive 5 by positive 3x will be positive 15x, and positive 5 by negative 4 will give us negative 20. So what I've done here is to expand, and let me simplify. So this will become 6x squared. Negative 8x plus 5x will give me positive 7x minus 20. And of course, nothing else can be done here because all three terms are not like terms. So let's look at another. So they want us to simplify this expression involving what? Algebraic expression involving fractions. So they want us to simplify this algebraic expression, x subtract 3 over 3 subtract x subtract 2 over 5. So to simplify this algebraic expression involving fractions, once you're adding or subtracting fractions, the first thing you do is to find the LCM. So the LCM of 3 and 5 will be 15. I divide the denominator 3 into my LCM 15 to give me 5. I'm going to multiply 5 by my numerator x minus 3. But to show that I'm multiplying 5 by an algebraic expression, because x minus 3 is an expression with two terms, we make sure that the expression with those two terms, x and negative 3, are placed within brackets. And of course, we bring down the subtraction sign separating the two algebraic fractions. And I do the same, I divide 5 into 15, which is 3. I'm going to multiply 3 by the algebraic expression x minus 2 with those two terms within the algebraic expression. So I'm going to ensure my algebraic expression is placed within brackets when I'm multiplying what is outside by the algebraic expression. We ensure the algebraic expression is within brackets. So let's expand, removing brackets and multiplying 5 by x, which will give me 5x. And I'm multiplying 5 by negative 3, which is negative 15. I'm going to multiply negative 3, not 3, but negative 3 by x to give me negative 3x. And I'm multiplying negative 3 by negative 2 to give me positive 6 all over 15. Of course, we're going to further simplify. In my numerator, I'm seeing like terms, so we can rearrange the terms in the numerator of this algebraic fraction, and this will become 5x, subtract 3x, and we have negative 15 plus 6 all over 15. Again, maintaining your LCM throughout each step. 5x subtract 3x will be 2x, and negative 15 plus 6 will give me negative 9 all over 15. And at this point, nothing else can be done, so that remains as your answer. Let's look at another. So they want us to simplify the expression, giving your answer as a single fraction. So you have an algebraic expression again in fraction form, and we want to simplify that expression. So what are we going to do? So again, once you're adding or subtracting algebraic fractions, you must find the LCM. Well, in fractions generally, once you're adding or subtracting, you must find the LCM. So I have 2m over n subtract 5m all over 3n. So you have to find the LCM. We're subtracting those two algebraic fractions. We find the LCM. I draw my line, and the LCM will be, of course, 1 is understood in front of n, so the LCM, lowest common multiple of 1 and 3 will be 3. And of course, n is the only variable in the denominator, so n will automatically be a part of the LCM. So my LCM there, it is 3n. So I look at the number in front of n, which is 1, the LCM of 1 and 3, it's 3. And because n is the only variable in the denominator, it is automatically a part of the LCM. So let me divide. I'm dividing my denominator n into 3n, which will give me 3. So I'm dividing 3n by n into n is 1, that gives me 3. I'm going to multiply 3 by 2n, which will give me 6n. I bring down my subtraction sign. I'm going to divide 3n into 3n, which will give me 1. If I divide 3n into itself, 3 into 3 is 1, n into n is 1. If I divide anything into itself, I get 1. So 3n into 3n is 1, and 1 multiplied by 5m, it is 5m. And of course, I want to simplify my numerator. Clearly, 6m subtract 5m, they are like terms. This will give me 1m or m. So if you want to put 1m, no problem, all over 3n, and that will be my answer. Nothing else can be done. So making sure that we can simplify algebraic expressions involving fractions when we are adding or subtracting. Okay? Let's look at another. So they want us to simplify the expression. Of course, you can simplify by multiplying quantities. Those are quantities or terms. So we have p cubed, q squared, multiplied by p cubed to the power of 5. So we want to simplify through multiplication. And this will also fall under indices, the rule of multiplication of indices. And when you're multiplying, the rule of multiplication states if you have a to the power of m multiplied by a to the power of n, once you have the same base, you call this a base, you maintain the base a and you add the powers. So I have p to the power of 3 by p to the power of 1. 1 is understood here, even though it's not seen, it's understood as 1. So this will be p to the power of 3 plus 1. I add my powers once the base are the same. Q to the power of 2 by q to the power of 5. Again, I'm multiplying, I keep the base, I have the same base, so I keep my base q, and I add my powers. So I'm going to get here p to the power of 4, q to the power of 7. And of course, that will be my final answer. Nothing else can be done there in simplifying that expression. Let's look at another. We ask to simplify. We have 3x squared times 4x cubed over 2x. So to simplify this expression, again, we are applying our laws of indices. The law of multiplication will occur in the numerator. When we get that result, we're going to divide it by 2x. So the law of division will come into play. So the law of division, so the rule will be division, this is multiplication. So the rule of division will be, if I have a to the power of m divided by a to the power of n, once I have the same base, I maintain the base a, and the powers you subtract. So this is the law of, or rule of division. So let's apply both multiplication and division to that question. So I'm multiplying my numerator. I can multiply 3 and 4, which are coefficients. We call them coefficients. They exist in front of the variable x. 3 by 4 will give me 12. X to the power of 2 by x to the power of 3. I'm applying my rule of multiplication. I have the same base x. I keep the x as my base and I add my powers. So this will give me 12x to the power of 5 all over 2x. So I have 12 x to the power of 5 over 2x. And let me apply now my rule of division. I can divide the coefficients 12 and 2. So 2 into 12 is 6. But x to the power of 5 divided by x, remember x has a power of 1, which is understood. So when you're dividing, once you have the same base, you keep the base x and the powers you subtract. So that's going to be 5 subtract 1. This is 6x to the power of 4. Alright, and that will be the final answer there when we simplify that expression. So applying your rule of multiplication and division. So let's look at another. So you can see algebraic expressions in the problem solving format. So we have here so they want us to change the following statements into algebraic expressions. So this is an algebraic expression 1. 4 times the sum of x and 5. 4 times. 4 times means to multiply. Sum means to add. So if we multiply 4 by the sum of x and 5, so that is x plus 5, I'm multiplying 4 by x plus 5, and must make sure my algebraic expression x plus 5 is in brackets. So I'm multiplying 4 by x plus 5, the sum of x and 5. 2, so this is an algebraic expression, 2, 16 larger than the product of a and b. Product means to multiply, so the product of a and b, and 16 larger than that. So the product of a and b will be a multiplied by b. You can write it as ab. A multiplication sign is understood between a and b, even though it's not seen, it's understood. If you want to write it as A multiplied by B, no problem, but A, B is the same. And 60 larger than this means we're going to add 16 to it. So that is 16 larger than the product of A and B. So making sure we understand, we see such in the exam, we are able to comfortably understand what is asked and answer accordingly. Yeah? So let's look at next another algebraic expression where we are converting these phrases into algebraic expressions. 1. 7 times the sum of x and y. So the sum of x and y, we know sum means addition, that is x plus y. And 7 times means to multiply, and multiplying 7 by this algebraic expression. So I make sure x plus y is placed in brackets. Good? Let's look at part 2. The product of two consecutive numbers when the smaller number is y. The product of two consecutive numbers. Consecutive numbers will be, if we have 1, 2, 3, 4, 5, those are consecutive numbers. Yeah? And of course, our counted numbers will move from one to the next by adding 1. If I add 1 to 1, I get 2, add 1 to 2, I get 3, add 1 to 3, I get 4, and so on. So the one product of two consecutive numbers where the smaller number is y. So the smaller number is y, and the number after that, because they're consecutive numbers, it means I have to add 1. Consecutive numbers, you have to add 1 to move to the next, yeah? So because y is smaller, then the number after y will be y plus 1. Yeah? Consecutive numbers. And I want the product of those two. Product means to multiply. So I make sure I place my y plus 1 in brackets. So this shows the product of two consecutive numbers where the smaller number it is y. Alright, the number after that will be y plus 1, and the brackets, of course, separating the two will show we are finding the product. Alright, so making sure that we understand our algebraic expressions. Okay, let's look at another. So again, you can see algebraic expressions as such, where they'll give you some shape and they'll ask you to write, for example, the perimeter of this quadrilateral as an expression in its simplest form. So the diagram below shows a quadrilateral with the length of its sides written in terms of x. You have the length of the sides written in terms of x. Write an expression. An expression, algebraic expression, has no equal sign. It's not an equation. You want an expression. Write an expression in terms of x for the perimeter of the quadrilateral. So the perimeter will be, the perimeter is distance around. So we're going to add 2x subtract 1, 2, 15 subtract 2x, 2, 3x subtract 7, 2, 2x plus 5. So we're adding all those sides. We are finding the perimeter. So if we want the expression in its simplest form, it means we have to, of course, simplify by doing what? Grouping like terms. This is 2x subtract 2x plus 3x plus 2x. Those are all like terms involving the variable x. Likewise, my constants are like terms. The constants will be your numbers, -1 plus 15. We have -7 plus 5. So we group all like terms. So the same expression, this is an expression, but we have it now where our terms are properly grouped. Rearrange, properly grouped, and let's simplify. So 2x subtract 2x is 0. 0 plus 3x, it's 3x. 3x plus 2x will be 5x. -1 plus 15, it is 14. 14 subtract 7, it is 7. 7 plus 5 will be plus 12. And that there is simplifying, finding the perimeter but we're representing the perimeter as an algebraic expression in its simplest form. Alright? So let's look at another. So we're moving on to substituting numbers for variables in an algebraic expression. So common questions, and these are all CSEC past paper questions I've put together. These are common questions you see in the CSEC exam. Let's make sure that we are clear on what we have to do. So let's look at it. So remember to share with your friends. Don't forget to share, like, and subscribe to my channel. So let's look at substituting numbers for variables in an algebraic expression. So if A is 2, B is -3, and C is 4, they want us to evaluate, they want us to find the value of AB subtract BC. So A is 2, B is -3, and C is equal to 4. They want us to find 1, AB subtract BC. So we're going to replace all these variables with numbers given. So AB means A multiplied by B, BC means B multiplied by C. And when you're multiplying two variables, it is always good if you're replacing those variables with numbers to show where, when the replacement or substitution is done, it's done so by using brackets. So if I have A, which is 2, times B, which is -3, I make sure I place both in brackets, which will also mean I'm implying multiplication. Subtract B -3 in brackets, C 4 in brackets. So let's multiply. 2 by -3 is -6. I hold this subtraction sign separating the product of B and C. So let me multiply -3 by 4, which will give me -12. But when two signs, they more or less clash as such, you separate by using what? Brackets. Yeah? And of course, what we want to do is to remove the brackets, because brackets mean or implies multiplication. This will be -6. A minus by A minus is A plus 12. And -6 plus 12 will give me +6. So very important. So we're replacing these variables in the algebraic expression. This is an algebraic expression. Replacing the variables, the letters, with the numbers given. And of course, we simplify to achieve our result. Let's look at part 2. We have B into A subtract C. And A subtract C is in brackets raised to a power of 2. I'm going to replace B with -3. Open brackets, I'm going to replace A with 2. Subtract, I'm going to replace C with 4. Close brackets, raise to the power of 2. What I'm going to do here now, you cannot multiply -3 by 2 and -3 by -4. Students often make that mistake because your 2 and -4 is raised to a power of 2, so you cannot remove the brackets. If you had a power of 1, which is understood, then you can remove the brackets. But if it's a power of 2, you cannot remove brackets just like that. So what you have to do is work out what you have inside the brackets. So this becomes -3. And of course, 2 subtract 4 is -2 squared. Yeah? Again, you can't say -3 by -2. You have to work out what is -2 squared first. And that result you multiply by -3. So this will become -3. -2 squared, we know it's -2 by itself. This will be -3 times and +4. -2 by -2 is +4. And -3 by +4 will give us -12. And that is the result. We replace those variables in the algebraic expression with the numbers given. So let's look at another. So all CSEC past paper questions, get into practice. You know the algebraic component is a major component, and let's make sure that the understanding is there. We're clear what we need to do. So find the value of each of the following when A is equal to 2, B is equal to -1, and C is equal to 3. So they want us to find the value of this algebraic expression. 1. A and in brackets B plus C. So I'm going to replace A with 2. Open brackets, I'm going to replace B with -1. Plus, I'm going to replace C with 3. Close brackets. If you want, now if you want to remove brackets, 2 by -1 and 2 by 3, positive 3, no problem. You can do so because the power is raised to 1, yeah? So you can remove the brackets. If not, you can work on what you have inside the brackets, which I will do. This is 2. -1 plus 3 is 2. And now you can remove your brackets by multiplying 2 by 2 to give you 4. So, substitution of variables or replacing variables in an algebraic expression with numbers given. Let's look at part 2. So we have 4b squared, subtract 2ac all over a plus b plus c. So let's replace all the variables with the numbers given. All the letters you see, they're called variables with the numbers given. This is 4. Open brackets, I'm going to replace b with -1 in brackets squared. Subtract. Now, 2ac. Now this is really -2 multiplied by a multiplied by c. -2ac. The multiplication sign, it's not seen, but it's understood between -2 and a, and of course a and c. So we multiply and we use brackets to imply or to represent multiplication, and also to separate our variables and replace them in numbers. So this is -2. And we replace a with 2, which is placed in brackets. And again, I'm going to replace c with 3, which is placed in brackets. Yeah? So that's -2 multiplied by a multiplied by c over, I'm going to replace a with 2 plus, I'm going to replace b with -1. But remember, when two signs collide or clash, we separate using brackets. Plus, I'm going to replace c with 3. So let's further simplify. Now, I'm not going to say 4 by -1. You cannot remove the brackets there because this is -1 raised to a power of 2. So you have to square -1 first, which is -1 by -1, positive 1. So that's 4 by positive 1. Let me multiply. -2 by 2 is -4. And -4 by 3 will give me -12. So this here is really 4 by 1. We put 4. Yeah? And of course, let's simplify. This will become 2 a plus by a minus. Remember, to remove that bracket requires your knowledge of multiplication. So I'm applying my rules of signs of multiplication. A plus by a minus is a minus. So I'm going to get -1 plus 3, which is equal to 4 minus 12 will give me -8 over 2 subtract 1, it is 1, and 1 plus 3 will give me 4. And -8 divided by 4, rules of signs of division, a minus divided by a plus is a minus, and 4 divided into 8 will give me 2. So my result there is -2. So we have replaced the variables with the numbers given. Remember, in a CSEC exam, when they are marking, you get marks for showing where the variables are replaced with numbers. So you get marks of those key steps, right? So make sure all steps are shown. All right, let's move on to another. So getting sufficient practice, so let's look at given A is equal to -1, B is 2, and c is equal to negative 3, they want us to find the value of 1a plus b plus c. So I'm going to replace a with negative 1 plus b with 2 plus c with negative 3. But I make sure I replace my positive sign and my negative 3 with brackets. This will be negative 1 plus 2. Let me remove the brackets by applying my rules of signs of multiplication. A plus by a minus is a minus 3. And now I can simplify very comfortably. Negative 1 plus 2 is 1, and 1 subtract 3 will give me negative 2. Let's look at part 2. B squared subtract c squared. I'm going to replace b with 2 in brackets squared. Subtract, I'm going to replace c with negative 3 in brackets squared. Showing the substitution. 2 squared, it's 2 by 2, which is 4. This is 2 by 2. Subtract negative 3 squared, negative 3 by negative 3. 2 by 2 will be 4. Subtract negative 3 by negative 3 is positive 9. And 4 subtract 9 will give me negative 5. Okay? So replacing those variables with the numbers given. Alright, so let's move on to what we call binary operations. Another very common topic under the algebraic component you see in the CSEC exam. Let's make sure you understand binary operations. So we have A, and we have that symbol of binary operation, just some symbol, and what it does, it will separate two variables or even numbers to give us a result. So you have here A asterisk B, it is equal to A squared subtract B. So this symbol, so think of an addition sign separating two numbers, and you know, of course, you're familiar with the operation of addition, subtraction, multiplication, and division. So this was an addition sign, we'll add these two numbers and we'll get a result. So the binary operation, what it does, it simply connects two numbers to give us a result. And the A squared minus B is your result. So if we have to evaluate 5 asterisk 2, then very simple, we know A will be equal to 5 and B will be equal to 2. And the A squared minus B will be the result, which will be obtained by simply replacing A with 5 and B with 2. So we know we can say, therefore, A squared minus B will be 5 in brackets squared, subtract 2, 5 squared is 25, subtract 2, which will give us 23 as the result. Straightforward, simple substitution. Let's look at another. So they gave us the expression. So you have a nice relationship here of A asterisk B and the expression, which is A plus B in brackets squared, subtract 2AB. So you have your very important relationship shown. They want you to calculate the value of 3 asterisk 4. So again, A will be equal to 3 and B will be equal to 4, and we will use the expression to help us to achieve the result. So we use the expression A plus B in brackets squared, subtract 2AB. Remember, this is negative 2 multiplied by A multiplied by B. So let's substitute or replace the variables in the expression with the numbers given. So this is open brackets 3 plus 4 in brackets squared, subtract 2. I'm going to replace A with 3, make sure that 3 is in brackets. I'm going to replace B with 4, make sure that 4 is in brackets. Let's simplify. 3 plus 4 will give us what? 3 plus 4 is 7 in brackets squared. And I'm going to multiply negative 2 by 3, it's negative 6. and negative 6 by 4 is negative 24. Let's simplify further. 7 squared, 7 by 7 will be 49. Subtract 24. And 49 subtract 24 will give us 25. And that is your result. Ensure you understand binary operations. It is a topic you see regularly in the exam under the algebraic component. Alright, let's look at another example here. So given that A asterisk B means the square root of A plus 4B. That means it will be the same as your equal sign, where the positive root is taken. So when you find the square root of any number, the positive and the negative result, it's always considered. Right? We have been trained to always focus on the positive result, but when you find the square root, you can obtain a negative result. Hence the reason why we have plus or minus in front of the square root symbol, considering both positive and negative results. Determine the value of 1 asterisk 2. So the same, we know that A is equal to 1 and B is equal to 2. So to find the value of 1 asterisk 2, we're using the expression to help us to achieve that. This is the square root. Replace A with 1 plus 4. Replace B with 2. So I make sure 2, it's in brackets. This is the square root of 1 plus 8. That's the square root of 9, which is 3. That's the result for part 1. Now part 2 asks us to state whether the operation denoted by the asterisk is commutative. And what is commutative? Commutative simply means they want us to show if 1 asterisk 2 is the same as 2 asterisk 1. So remember the commutative law, 2 multiplied by 3 is the same as 3 multiplied by 2. That's a commutative law. 2 by 3 is the same as 3 by 2. Yeah? Or 1 plus 2 is the same as 2 plus 1. The commutative law of multiplication and addition. So let's determine if we're going to get the same result with 2 asterisk 1 if it's commutative. 1 asterisk 2 is commutative to 2 asterisk 1. So we have the result for 1 asterisk 2. Let's find 2 asterisk 1. So I'm going to say here let. So we can have 2 asterisk 1. So I'm going to let A be equal to 2 and B be equal to 1. And let me use my expression to achieve my result. This will be the square root of A plus 4B. So I'm going to replace A with 2 plus 4, and I'm going to replace B with 1. But remember that's 4 multiplied by B, so make sure that 1 is in brackets. So this will become square root of 2 plus 4, and that will be the square root of 6. So what can we say? We can say therefore 1 asterisk 2 is not equal to 2 asterisk 1. Good? So it's not commutative. Not commutative. So it is not commutative. Okay? So understanding our binary operation. Alright, let's move on. So we're looking at a few topics today, key topics under the algebraic component. We're looking at factorization, which we see in the exam almost every year. You're asked to factorize. So they want us to factorize the following expressions. So you factorize expressions, and when you factorize an expression, you represent your answer as a product of factors. That's factorization. You take an expression and you represent it as a product. So if I have, for example, let's take a simple number, 6. Factors of 6 are 1, 2, 3, and 6. So when I multiply factors of 6, 2 and 3, when I multiply 2 by 3 to give me 6, this is factorization. I've represented 6 as a product of factors. So I want to represent each of those expressions on the board there as a product of factors. I have to show where it's represented as such. So, to do so, with factorization, you have to understand all the methods of factorization. There are 4 methods. 4 common, very common methods you need to know. The methods are 1, the highest common factor method, HCF method, where we have to identify factors that are common. We take out as a factor and then we divide into each term of the expression. This is the HCF method. The second method is the grouping method, which is used when you have or you see 4 terms in the expression. Sometimes I've already seen 2. We can use the method of grouping because I have 1, 2, 3, 4 terms in the expression. The third method of factorization is the difference of 2 perfect squares. The difference of 2 perfect squares. So of course, difference means subtraction, and 2 perfect squares. So a perfect square, of course, is any number, or it can be a term or even a variable where a factor of that term or number times itself will give you the number. So for example, 9. Factor of 9 is what? 3. So 3 times itself will give you 9. Hence 9 is a perfect square. So 9, for example, is a perfect square. Subtract. Let's think of another perfect square. A squared is a perfect square. A can be expressed as a product of the same factor, which is A. A by A gives you A squared. So therefore, what we have here are 2 perfect squares, and the subtraction sign between it represents the difference of 2 perfect squares. So understand, what is a perfect square? It is any term whose factor, if you have a factor, that factor times itself will give you the number or term or expression, and hence that is what is known as a perfect square. And of course, the subtraction sign between it represents a difference. So you have 4. We have the quadratic expression. And now when I look at in terms of the difference of 2 perfect squares, I've already seen where 1 is the difference of 2 perfect squares. 4x squared minus 25. 4x squared is a perfect square. It's the same as 2x by 2x. Product of the same factor. 25 is a perfect square. 5 by 5. Product of the same factor. And of course, I have a subtraction sign separating it. So I already see the difference of 2 perfect squares. The third or fourth method, it is the quadratic expression, which is always of this form. And the third is of that form. So I'm going to factorize that expression and use the method of the quadratic expression. So let's factorize. So we have stated the methods, and let's factorize using the method shown. So 1. 4x squared subtract 25. You want to represent that expression as a product of factors. When I look at that, clearly it's a difference, subtraction of 2 perfect squares. So I can represent 4x squared as a product of the same factor, which is 2x by 2x. Product of the same factor will give you 4x squared. I can represent 25 as a product of the same factor, 5 by 5 will give me 25. So 2 perfect squares, the subtraction sign is the difference. So let me represent it as a product of factors. This is what I do. You place 2 sets of brackets showing the product. And of course, 2x, which are the factors of 4x squared. Because 4x squared leads, I'm going to put the factors of 4x squared, 2x first in each bracket. And I'm going to take the factors of 25, 5, and I'm going to place it after. And I must separate. In one bracket, I must have a positive sign, and the other I must have a negative. Or it can be reverse, negative, positive. But you have 2 different signs, alright? So this is factorizing. This is taking the expression and representing it as a product of factors. That's factorization. If you were to multiply these two, and we just did expansion of binomials, right? If you expand these two, you can apply your knowledge to it. You're going to see where you're going to get back your original expression. Let's look at 2. 6p minus 9ps plus 4q minus 6qs. So to factorize this expression using the method of grouping, because we have 1, 2, 3, 4 terms. So I'm going to split it into 2 pairs. Alright, and we're going to factorize using the highest common factor to each pair. So each pair we're going to factorize using the HCF method. So what is the highest common factor? Look at your numbers 6 and 9. The highest common factor of 6 and 9 will be 3. If I look, p is also common to each term in my first pair. P is common, so I'm going to take out p as my highest common factor as well. So the highest common factor is 3p. I'm going to put my brackets, and now I'm factorizing each pair, so I'm representing each of these pairs as a product of factors. So I'm doing that in the first pair. So let me divide 3p into 6p. 3 into 6 is 2. When I divide p into itself, I'm going to get 1. So I have 2. So 3p into 6p will give me 2. Let me divide 3p into negative 9ps. A minus divided by a plus is a minus. 3 divided into 9 is 3. P divided into itself is 1, and I'm left with s. So 3p and in brackets 2 minus 3s is factorizing this first pair. Let me factorize my second pair. Always remember, the sign controlling the first term of the second pair, it is automatically a part of the highest common factor. So what else is common? Look at your numbers 4 and 6. The highest common factor of 4 and 6 is 2. What else is common to each term in that second pair? Q. So I'm going to take out Q as part of my highest common factor. So my highest common factor of the second pair is 2Q. So now let me divide 2Q into each term of the second pair. So I'm going to divide 2 into 4, it's 2. Q divided into itself, it's 1. So you have 2 when you divide 2Q into 4Q. Let's divide 2Q, positive 2Q, into negative 6QS. A minus divided by a plus is a minus. 2 into 6 is 3. Q into Q is 1. Q into itself is 1, and you're left with S. So when we are factorizing, or we have factorized each pair, once we have the same expression in brackets, so we have the same expression in brackets, it means you are on the right track, you're doing it correctly. If you did not get the same expression, then something is wrong. You double check your factorization of each pair. You must get the same variables, same signs. So now let's further factorize and get our final answer to represent the expression as a product of factors. So it means I'm going to take out now my 2 minus 3s, because this is common. So you take it out as a factor, and what remains, which is a 3p and a positive 2q, you can place in the other bracket. And you're factorizing, you've taken this expression and you've represented it as a product of factors. That's factorization. Yeah? Let's look at the third. We have 3x squared plus 4x subtract 4. So for me to factorize that expression, the method I'm going to use is the method of the quadratic expression. Let's make sure we can recognize what expression is applicable to. What method is applicable to the given expression. So I'm using the quadratic expression, and how do I start? I'm going to multiply A by C. A in this case, it's a number in front of x, which is 3. C, it is negative 4. So I'm going to multiply 3 times negative 4, which is negative 12. So 3 multiplied by negative 4, it's negative 12. Then I want 2 factors of negative 12, very important part. 2 factors of negative 12. When you multiply those 2 factors, you're going to get negative 12. But when you add them or subtract them, it can help you to get your middle term plus 4x. So 2 factors of negative 12. When multiplied will give me negative 12. But when added or subtracted can help me to get positive 4x. And the 2 factors of negative 12 we can think of are 6, positive 6, multiplied by negative 2. So positive 6 by negative 2 gives me negative 12. But take positive 6, attach x to it, take negative 2, attach x to it, and we are going to get here positive 6x subtract 2x will give us 4x, my middle term. I've achieved it. So what is the next step? After I've achieved or I've got my 2 terms that can assist me in finding my middle term, then I'm going to rewrite my expression as 3x squared. I'm replacing plus 4x with plus 6x minus 2x minus 4. So since I've moved from 3 terms to 4 terms, and what I'm going to do now is use my method of grouping to factorize it. So I'm going to split it into 2 pairs. What is common to the first pair? Clearly 3. And x is also common. You have x squared and you have x. When you take out x with the lower power, this is x to the power of 1. So when you're using the highest common factor method, if you see you have variables common, you take out the variable with the lower power. That will be a part of your highest common factor. So I'm going to take out x to the power of 1. So 3x becomes my highest common factor. Let me divide 3x into 3x squared. 3 into 3 is 1. X into x squared will give me x. Let me divide 3x into plus 6x. 3 into plus 6 will give me plus 2. X divided into itself will give you 1. So I have x plus 2 within the brackets. Let me factorize my second pair. The sign controlling the first term of the second pair is automatically a part of your highest common factor. If you look here, 2 is also common to each term of the second pair. So I take out 2. So negative 2 becomes my highest common factor of the second pair. And let me divide negative 2 into each term of the second pair. My highest common factor, negative 2 of the second pair. Let me divide it into each term. Negative 2 divided into negative 2x. Negative 2 into itself will give you 1, and you're going to be left with x. Let me divide negative 2 into negative 4. Negative 2 into negative 4. A minus divided by a minus is a plus. 2 into 4 will give you 2. If I look, I have the same expression in brackets. X plus 2, it is a common to each. And once I have the same thing in brackets, I know I'm on the right track. All I have to do now is carry out one more step, which is to further factorize. So I'm going to take out x plus 2, which is common, and take it out as a factor. And what remains, which is 3x and negative 2, will be placed in the other bracket. And I factorize, I've represented the expression, this expression here, as a product of factors. If you were to multiply, we did expansion of binomials earlier, if you were to multiply these two, you get back the original. If you multiply these two, you get back the original. Multiply those two, you get back the original. Alright? So we have factorized. Let's look at some other examples here with factorize or expressions to factorize. We have here factorize completely 1. 6a squared b cubed plus 12a to the power 4b. So, what method of factorization are we going to use here? We're going to use the method of the highest common factor. It can be grouped, we don't have 4 terms. It can be the difference of 2 perfect squares. These two are not perfect squares, and I have an addition sign separated on a subtraction. It can be the quadratic expression, which is not of the form ax squared plus bx plus c. So the only method is the method of the HCF. So let's factorize it. What is the highest common factor of 6 and 12? It is 6, not 2, not 3. 2 can divide into 6 and 12, yes. 3 can divide into 6 and 12, yes. But you want the highest common factor, which is 6. 6 can divide into itself and 12, so you take out 6 as part of the highest common factor. A is common to both, yes. But you are always going to take out the variable with the lower power. So you're going to take out a with the lower power, which is a squared. B is common to both, yes. But you're going to take out b with the lower power. So b with the lower power will be part of the highest common factor. That's b to the power 1, which is understood. 1 is understood. So you take out b. So 6a squared b is your highest common factor. Make sure you have your brackets, because you have to represent it as a product. Brackets will imply multiplication. Let me divide 6a squared b into each term. 6 into 6 is 1. A squared into itself is 1. B divided into b cubed gives me b squared. Let me divide the highest common factor into my second term. A plus divided by a plus is a plus. 6 into 12 is 2. A squared into a to the power 4 gives me a squared. And b into itself is 1. Close brackets. So 6 into 6 is 1 times a squared into itself is 1 times b into b cubed b squared. 1 by 1 by b squared gives me b squared. Let me divide the highest common factor into the second. 6 into 12 is 2 times a squared into a to the power 4 is a squared times b divided into itself is 1. So 2 by a squared by 1 gives me 2a squared. I factorized it. I've represented the expression as a product of factors. Let's look at the second. Factorize 2m squared plus 9m minus 5. So what method of factorization are we going to apply here? The method of the quadratic expression. It can be HCF. It can be grouping. We don't have 4 terms. It can be the difference of 2 perfect squares, but it is of this form. So let's factorize. So we're going to multiply a, which is 2, by c, which is negative 5, to give me negative 10. And I want 2 factors of negative 10. When multiplied, will give me negative 10. But when added or subtracted, can help me to find positive 9. So the 2 factors of negative 10 will be, that will be positive 10 by negative 1. Positive 10 by negative 1 gives me negative 10, but positive 10 attach m and negative 1 attach m will give me positive 9. So I've achieved my middle term. And what we're going to do now is to rewrite the expression as 2m squared and replacing positive 9m with positive 10m, subtract 1m, and of course maintain negative 5. So I'll move from 3 terms to 4. And with a pair of using grouping now, so I'm using the method of grouping to further factorize. So I split into two pairs. What is common to my first pair? Clearly 2. And if you look, m is common, we'll take out m in the lower power. So let me divide. 2 into 2 is 1, m into m squared is m. Let me divide 2m into plus 5, plus 10m. 2 into plus 10 is plus 5. M into m is 1. So 2m into plus 10m will be plus 5. Close brackets. Let me factorize my second pair. So the sign controlling the first term of the second pair, you take out automatically as part of your highest common factor. There's nothing common to m and 5, but what is understood after a negative sign is 1. So negative 1 is your highest common factor. Let me divide negative 1 into negative m. A minus divided by a minus is a plus. 1 into m is m. Let me divide negative 1 into negative 5. A minus divided by a minus is a plus. 1 into 5 is 5. We have the same expression in brackets, so you know you're on the right track. So your last step now is to take out m plus 5, which is common, and what remains, 2m and negative 1 will be placed in the other bracket. And you have factorized the expression, representing it as a product of factors. Alright, let's look at another. Make sure we get a practice. Right, so 1, factorize 4y squared minus z squared. The method we're going to use is the method of the difference of two perfect squares. Each of those two terms are perfect squares. Each of the terms, are perfect squares. So this is 2y by 2y. That's why 4y squared is a perfect square. And z by z. That's why z squared is a perfect square. Then you put your two sets of brackets. Because 4y squared leads, the factors of 4y squared will be placed first in each bracket. And because z squared is after, the factors of z squared will be written next. And you separate with a plus in one and a minus in the other. You can have minus first, plus sign after. It doesn't matter the order. So you have factorized it, you have represented it as a product of factors. Let's look at part 2. 2ax subtract 2ay minus bx plus by. I have how many terms? 1, 2, 3, 4. So I'm using the method of what? Grouping. So I split into two pairs. What is common to my first pair? Clearly 2 and a. Open brackets. Let me divide. 2a into 2ax. 2 into 2 is 1. A into a is 1. You're left with x. Let me divide 2a into negative 2ay. A minus divided by a plus is a minus. 2 into 2 is 1. A into a is 1. You're left with y. The sign controlling the first term of the second pair, I bring down that sign automatically. B is common to each term of the second pair, so I take out B. So negative B is my highest common factor. Let me divide negative B into each term. Negative B into negative B is 1, you're left with x. Let me divide negative B into plus by. A plus divided by a minus is a minus. B into B is 1, and you're left with y. We are on the right track because we have the same expression, x minus y in brackets. So we have one more step. We should take out x minus y as your common factor. You take it out as a factor, and what remains, which is your 2a and negative b, you place in the other bracket. And you have factorized it. Yeah? So let's look at the last 3. So what I will do, I will erase the 2. Let's do the last in this slide. We have 3. squared plus 10x subtract 8. Clearly to factorize, I'll be using the method of the quadratic expression. So we're going to multiply 3 by negative 8, which is negative 24. And 2 factors of negative 24, when multiplied, will give you negative 24. But when added or subtracted, can help you to get your middle term plus x. And the 2 factors of negative 24 we can use, we can say this will be, we can say positive 12 by negative 2. So positive 12 by negative 2 will give negative 24, but positive 12 will attach x, and negative 2 attach x will give us 10x, your middle term achieved. And once you arrive at your middle term, you're going to rewrite the expression as 3x squared replacing plus 10x with plus 12x minus 2x minus 8. You're going to split into 2 pairs. What is common to my first pair? What is common to 3 and 12? Clearly 3. X is also common to each term, so I'll take out x in the power of 1, which is x, of course. And let me divide 3x into 3x squared. 3 into 3 is 1, x into x squared is x. Let me divide 3x into plus 12x. A plus divided by a plus is a plus. 3 into 12 is 4, x into x is 1. So you have x plus 4 in brackets. Let me factorize my second pair. The sign controlling the first term of the second pair. Bring on that sign automatically. If you look, 2 is common to itself and 8, so I take out 2, that's the highest common factor. So negative 2 is my highest common factor. Now let me divide negative 2 into each term, open bracket. Negative 2 into negative 2 is 1, yeah? And of course I left with x. Let me divide negative 2 into negative 8. A minus divided by a minus is a plus. 2 into 8 is 4. So we are on the right track because we have the same expression in brackets. We have one more step, which is to take out x plus 4, which is common, and what remains is 3x and negative 2, replace in the other bracket. Again, it doesn't matter the order. If you have 3x minus 2 first and x plus 4 after, that is okay. It does not matter the order. Okay? So, let's look at one more with regards to factorization. We can show a clear on factorization. So see different expressions how to factorize 1. xy cubed plus x squared y. The method of factorization we're going to use here is the highest common factor. If we look, x is common to both, but I'm going to take out x with the lower power. Y is common to both, but I'm going to take out y with the lower power. This is y to the power 1. So take out y with the lower power. So my highest common factor is xy. Let me divide this highest common factor into each term. X divided into itself will give you 1. And y divided into y cubed will give you y squared. Let me divide the highest common factor into the second term. A plus divided by a plus is a plus. X divided into x squared will give you x. And y divided into itself is 1. So therefore, y squared plus x will be what is obtained in brackets. And the highest common factor is xy. We have represented it as the product of factors you have factorized. Let's look at 2. 2mh minus 2nh minus 3mk plus 3nk. So the method of grouping, 1, 2, 3, 4 terms. So we're going to split into 2 pairs. What is common to the first pair? Clearly 2 is common. If we look as well, h is common. So 2h will be my highest common factor. Let me divide 2h into each term. 2 into 2 is 1, h into h is 1, I'm left with m. Let's divide 2h into negative 2hn. A minus divided by a plus is a minus. 2 into 2 is 1, h into h is 1, you're left with n. Let me factorize the second pair. We sign controlling the first term of the second pair. Make sure I state and show that sign. What else is common? 3 is common to each pair. What else is common? K is common to each pair. So negative 3k is my highest common factor. So let's divide. Negative 3 into negative 3 is 1. K into k is 1. You're left with m. Let's divide negative 3k into positive 3kn. So a plus divided by a minus is a minus. 3 into 3 is 1. So negative positive 3 divided by negative 3 will give me negative 1 plus or negative. A plus divided by a minus is a minus. 3 into 3 is 1. K into k is 1 and then left with n. We have the same expression in brackets, so we know we're on the right track. So I have one more step. I take out what is common, m minus n. That's common to each. Take it out as a factor. And what remains, 2h and negative 3k, I can place in the other line. I have factorized. Okay? So understanding factorization. Okay, so let's look at when we have a merge of simplification and factorization, a merge of the two. That's all. Let's So let's look at simplification and factorization. So let's get familiar with this type of question. They want us to simplify 1, x squared minus 1 over x subtract 1. Now, this here, mistake students make, they divide x into x squared and they divide 1 into 1. That's incorrect. So, the trick with this question will involve factorization. So, hence the reason it's a merge of simplification and factorization. So, the numerator we can factorize, and the method we're going to use here is the method of the difference of two perfect squares. X squared subtract 1 is the same as x by x, 1 by 1. Two perfect squares, the subtraction sign represents the difference. So I can represent x squared minus 1 as a product of factors. Because x squared leads, x will be placed first in each bracket, and then the factors of 1 will be written after. And I must separate with the positive sign and negative. Positive in one, negative in the other, over x subtract 1. And what can happen here, for me to simplify it now, I'm going to divide x subtract 1 into x subtract 1. And of course, I'm going to be left with x plus 1. So I can divide this into itself to give me 1, and I'm left with x plus 1. So this is simplifying but using factorization to help you simplify it. Let's look at part 2. So they ask you to simplify, and we have 4a squared ab squared plus 2a squared b over ab. Now the mistake made by students, they will divide this, we'll cancel this a with that a, cancel that b with that b, and so on. So we're not doing that. To simplify this, what we're going to do is to carry out our method of factorization to help us to simplify. So we're going to factorize in numerator. So if we look, what is common to 4 and 2? Clearly it's 2. If we look, a is also common, so you can take out a, of course a with the lower power, which is a to the power of 1. B is also common, so I can take out b. B is, of course, b to the power of 1, that's the lower power, b to the power of 1, so I take it on as a factor. And let me divide 2ab into each term. 2 into 4 is 2, a into itself is 1, b into b squared is b. Let me divide 2ab into my second term plus 2 into 2 is 1, a into a squared is a, b into itself is 1. So that's me factorizing my numerator over ab. So now what I can do, I can divide, because it's 2ab multiplied by 2b plus a, I've represented the expression as a product of factors. What I can do is to divide ab into 2ab. So I can simply say a into a is 1, b into b is 1, and I'm going to be left with 2 into 2b plus a. And this is me simplifying using the method of factorization. I have to factorize my numerator first, and then I can simplify to get my final result. Let's look at another. So they want us to factorize a and b, but then we have part 2 of this question, hence simplify the expression. So part 1 and 2 they want us to factorize, and then part 2 they want us to simplify the expression. So let's look at this example or question. All C-set past paper question. So let's test our knowledge of factorization. 1. Part A, factorize xy minus y squared. Clearly the method of factorization we're going to use there is the method of the highest common factor. So if we look, y is common to both, so I'm going to take out y with the lower power, y to the power of 1, that's the only highest common factor there. I have my brackets, and let me divide. y into y is 1, and I'm left with x. And let me divide. Y into negative y squared, a minus divided by a plus is a minus. When I divide y into y squared, I get y. That is me factorizing the expression in A. Let me factorize the expression in B. X squared minus y squared. The method of factorization I'm going to apply is the difference of two perfect squares. X squared is a perfect square. I can represent it as a product of factors. Y squared is a perfect square. I can represent it as a product of factors. And therefore, I will have my two sets of brackets. Because x squared leads, the factors of x squared will be written first, and the factors of y squared will be written after. And you separate with a positive sign, negative, or if you want to do the reverse, negative, positive, and you factorize your expression in B. But then look at part 2 of this exercise and simplify xy minus y squared all over x squared minus y squared. What we're not going to do here is divide x into x squared and y squared into we're not going to do that. We have already done most of the work. We will have factorized xy minus y squared in part A. So this is y, x minus y over. We've already factorized x squared minus y squared in B. We have x plus y, x minus y. And all we have to do now is simplify. I'm going to divide x minus y into itself to give me 1. And therefore I'm going to be left with y all over x plus 1. And that there is the result. So merging simplification and factorization. So let's look at this here as well. Factorize each of the following and hence simplify the expression. So let's look at this also. So the same concept. So let's factorize each of the following and then simplify. So again, understanding how important factorization is. A, factorize x squared minus 49. The method of factorization that we use there is the method of the difference of two perfect squares. X squared is a perfect square. I can represent it as a product of the same factor. 49 is a perfect square. I can represent as a product of the same factor. And what I can do here, I have my two sets of brackets. The factors of x squared will be written in each bracket first. Then the factors of 49 will be written after. And we separate plus minus. If you want to write minus plus, it does not matter the order. Let's look at B. Factorize x squared plus 2x minus 35. The method of factorization will be used here as a method of the quadratic expression. 1 is understood in front of x squared, it's understood. So I'm going to multiply 1 by negative 35, which is negative 35. So I'm multiplying A by C. And I want two factors of negative 35. When multiplied will give me negative 35, but when added or subtracted can help me to find that middle term plus 2x. And the two factors of negative 35 I can use is positive 7 by negative 5. That will give me negative 35, but positive 7 attach x and negative 5 attach x. 7x subtract 5x, positive 7x subtract 5x gives me 2x. My middle term achieved. And what we're going to do is to rewrite the expression as x squared plus 7x minus 5x minus 35. When I move from 3 terms to 4, and we pair off what is common to the first pair, clearly x. So I divide x into x squared to give me x. I divide x into plus 7x to give me plus 7. Let me factorize the second pair. The sign controlling the first term of the second pair I bring down automatically. What else is common to the second pair? 5. So negative 5 becomes the highest common factor. So I divide negative 5 into negative 5x will give me x. And negative 5 into negative 35 will give me plus 7. So x plus 7 is common to both. So I know I'm on the right track. So I can take out x plus 7 and x subtract 5. So that's part A, part B. Now let's look at part C. Hence, simplify the expression. So what is to simplify that expression? Part 3. You want me to simplify x squared minus 49 all over x squared plus 2x minus 35. So how am I going to simplify that? All the work I would have done already. I did it in part A. So I'm going to replace x squared minus 49 with x plus 7, x minus 7 over, I factorize what's in the denominator, which I'll write as x plus 7 and x minus 5. So all the work I would have done already, and all I have to do is simply divide x plus 7 into itself, and I will be left with x minus 7 over x minus 5. And that is merging, factorization, and simplification. Alright, so I've simplified to get that result. Alright, let's look at equations. So, remember, we simplify expressions, but we solve equations. We simplify expressions, but solve equations. So, they want us to, of course, we can see equations in a problem solving format. In this case, they just wanted us to create the equation. Write an equation in X with respect to each statement below. Do not solve the equation. Let's write an equation. When 4 is added to a certain number, the result is the same as halving the number and adding 10. So when 4 is added to a certain number, we don't know the number, let's call the number x. 4 is added to that number. The result, what is it equal to? Half the number, remember the number is x, we consider the number to be x. Half the number and adding 10. That is your equation that created. So you can see questions like this. These are all C-set past paper questions. Part 2. Squaring a number. We don't know the number, but squaring a number is writing that number as x squared. Let's assume the number is x. So we're gonna square x. That's squaring a number, and subtracting 6 gives the same result, which is an equal sign, as doubling the number. Doubling means to multiply by 2. The number is x. So I double the number, multiply by 2, adding 9. We have created an equation. So they want us to create the equation, not solve it. Okay? Let's look at the other. Solve the equations. They want us to solve these equations. So we have r plus 3 is equal to 3 into r subtract 5. Simple equation to solve. So of course, we see brackets, so let's remove the brackets first. R plus 3, and let me remove the brackets. 3 by r is 3r. 3 by negative 5 is negative 15. So I want all my terms with r on the left side preferably. I want all numbers on the right side preferably. So we can move positive 3r over to the left as negative 3r, or we can subtract 3r from both sides using what we call the balancing method. So we can say here, if you want to use that method, 3r subtract 3r Because it's positive 3r, I have to subtract 3r with the opposite in operation. Subtract 15. So if I subtract 3r from positive 3r, what I do to one side I must do to the other. I subtract 3r from r, maintain plus 3. This is the balancing method. So you can bring the 3r over and change the sign, no problem. R minus 3r is negative 2r plus 3. 3r minus 3r is 0, and left with negative 15. Let me solve for r. So the first thing I'm going to do is to remove positive 3. How do I remove positive 3? You can bring it over on the other side of the equal sign as negative 3. Or you can subtract 3 from both sides. Alright? Because it's positive 3, it will be opposite in operation, which is to subtract 3. So now I want to remove that 3. Alright? Then I'm going to remove the negative 2 to get r by itself. Right? So removing positive 3. Those two will cancel to become 0. You're left with negative 2r is equal to negative 15 subtract 3 is negative 18. But then to get r by itself, you want to remove negative 2. And this is negative 2 multiplied by r. A multiplication sign is understood between negative 2 and r. What's the opposite of multiplication? Division. So you can just simply divide negative 2r by the number in front of r, which is negative 2. And what you do to one side, you must do to the other. I divide negative 18 by negative 2. So when my two negative 2's divide into each other, so they give me 1. R stands alone. And negative 18 divided by negative 2 is positive 9. So solving equations. Now what I did here is to use the balancing method approach. Alright, let's look at another. Solve the equation. So I want us to solve 15 subtract 4x is equal to 2 into 3x plus 1. So let us solve that equation. So I see bracket. My first step is to remove the bracket. So this is 15 subtract 4x is equal to 2 by 3x, which is 6x. 2 by positive 1 is positive 2. I want all my x's on the left. So you see there's 6x on the right, I want it gone. So you can either take this 6x and bring it over to the left, change the sign, or you can use the balancing method approach to remove this 6x. Because it's positive 6x, I subtract 6x from positive 6x plus 2 carry the opposite in operation. And what you do to one side, you do to the other, and we subtract 6x from negative 4x. So we're going to get here 15. Negative 4x subtract 6x will be negative 10x. Of course, 6x minus 6x is 0. And we're going to be left with 2. Now, what we want to do is to get x by itself. So to get x by itself, I have to remove my 15 and negative 10. I'm going to remove my 15 first. Then my negative 10 after. How do I remove positive 15? I do the opposite in operation, just to subtract 15 from positive 15 minus 10x. And what I do to one side, I do to the other. I subtract 15 from 2. So 15 minus 15 is 0. I'm going to be left with negative 10x is equal to 2 minus 15. It's negative 13. But then to get x by itself, I have to remove my negative 10 from in front of x. That's negative 10 multiplied by x. And the opposite of multiplication is division. So I divide negative 10x by negative 10. And what I do to one side, I do to the other. I divide negative 13 by negative 10. And when my two negative 10s divide into each other to give me 1, I'm left with x, which is equal to a minus divided by a minus is a plus, positive 13 all over 10, which is 1 and 3 tenths. That's the answer. So you can either you can either bring it across, change the sign, or you can use the balancing method approach to help you to solve the equation. Let's look at another. So they want us to all past paper questions. Solve for P. So we have 2 and in brackets P plus 5 minus 7 is equal to 4P. So I'm going to remove my brackets. This is 2 by P is 2P. 2 by positive 5 is positive 10. Minus 7 is equal to 4P. Let me get all my P's on the left. So I'm going to remove this 4P. Or what I will do first, let me simplify what is on the left hand side. I have positive 10 and negative 7, so I'm going to write this as 2P plus 7 plus 10, sorry, minus 7 is positive 3 is equal to 4P. And now I want all my P's on the left, so I'm going to remove this 4P from the right hand side by subtracting 4P from itself. It's positive 4P, so I carry the opposite in operation. And what I do to one side, I do to the other. So I'm going to get here 2P subtract 4P. It's negative 2P plus 3. 4P minus 4P is 0. And now to get P by itself, I'm going to remove positive 3 and negative 2. Removing positive 3 first by subtracting 3 from both sides. So 3 minus 3 is 0. I'm left with negative 2P. 0 minus 3 is negative 3. And therefore to get P by itself, I need to remove negative 2. So the opposite of multiplication is division. So I'm going to divide negative 2P by the number in front of P, which is negative 2. And what we do to one side, we do to the other. So my two 2's divide into each other to give me 1. P stands alone, which will give me positive 3 over 2, or 1.5. Alright, solving our equations. Right, let's look at an equation involving fractions. Let's see if we can solve our equations where fractions are involved. So we have x all over 2 plus x all over 3 is equal to 5. Now you never solve an equation involving fractions. The aim is to remove the fraction. So one approach is, when you have an equation involving fractions, is we can simplify what we have on the left. We learned how to simplify expressions involving fractions. So let's simplify what we have on the left. So this will be, find the LCM 6. 2 divided into 6 is 3. 3 by x will be 3x. Bring down the addition sign. 3 into 6 is 2. 2 by x will give us 2x. Yeah? Of course, I'm going to maintain my equal to 5. 3x plus 2x will give me 5x over 6 is equal to 5. So this is me removing or simplifying what I have on the left to 5x over 6. Now, this is 5 over 1, because we have two fractions, one fraction on the left, one fraction on the right. Anytime you have one fraction on the left, one fraction on the right, you can carry out something called cross multiplication. One fraction on the left, one fraction on the right of the equal sign, cross multiply. 1 by 5x is 5x, and the 5x can be on this side also. 6 by 5 is 13. No more fractions. Then I can divide both sides by 5 to give me my final result. 5x over 5, 13 over 5. X is equal to 6. Solving our equations involving fractions. Okay? Let's look at this equation. Let's solve this equation involving fractions. We have here 2x, subtract 3 all over 3, plus 5 subtract x over 2 is equal to 3. Again, we do the same, we simplify what we have on the left. So I find my LCM, which is what? 6. I divide 3 into 6, which is 2. And I'm going to multiply 2 by the numerator, 2x minus 3. If I'm multiplying a number by an expression, I must put the expression in brackets. So it's going to be 2 times 2x minus 3 plus. I divide 2 into 6 is 3. I'm multiplying 3 by the expression in the numerator, 5 minus x. So I'm going to write 3, and I'm going to put 5 minus x in brackets is equal to 3. Let me simplify what I have on the left hand side. So I'm going to remove my brackets. 2 by 2x is 4x. 2 by negative 3 is negative 6. Positive 3 by 5 is positive 15. Positive 3 by negative x is negative 3x. All over 6 is equal to 3. Let me further simplify what I have on the left. So this is 4x subtract 3x. You can group by terms. 4x subtract 3x will give us x. And negative 6 plus 15 is positive 9. All over 6 is equal to 3. All over 1. And 3 is a fraction. You can write it as 3 over 1. But you never solve an equation with fractions. You have one fraction on the left, one fraction on the right. So you can carry out what you call cross multiplication. So 1 by x plus 9 will give us x plus 9. And 6 by 3 will give us 18. No more fractions. And therefore we can solve for x by subtracting 9 from both sides. And therefore x is equal to 9. Okay? So making sure we understand how to solve our equations, especially those where fractions are involved. Alright, let's look at this one. So all CSEC past paper questions, don't forget to like, share and subscribe. So if we have 3 all over 7x subtract 1 plus 1 over x is equal to 0. So again, let us simplify what we have on the left. So we have fractions, we find the LCM. And the LCM will be 1 of each. X, 1 of each, and 7x subtract 1. That's the LCM, 1 of each. So I'm dividing 7x subtract 1 into the LCM. 7x subtract 1 into 7x subtract 1 will give us x. X by 3 will give us 3x. Bring down the addition sign plus. X divided into x is 1. So I'm left with 7x subtract 1. 1 by 7x subtract 1 will give me 7x subtract 1 is equal to 0. Let me simplify what I have on the left further. I have my like term, 7x plus 3x will be 10x subtract 1 over x into 7x subtract 1 is equal to 0. 0 can be written as a fraction. You can write 0 as 0 over 1. And what we're going to do, when you have one fraction on the left, one fraction on the right, you can carry out what we call cross multiplication. So 1 by 10x subtract 1, it is 10x subtract 1. And x into 7x subtract 1 by 0, anything by 0, it is what? 0. So no more fractions. So let's solve that equation. So I'm going to remove negative 1 by adding 1 to both sides. My negative 1, positive 1 will cancel out to become 0. I'm left with 10x. which is equal to 1, and therefore to get x by itself, I divide both sides by 10. 10x over 10, 1 over 10, x is equal to 1/10. Alright? So making sure we are clear on how to carry out the process and steps in solving an equation where fractions are involved. Alright, let's look at simplification and equations. So merging the two. Merging the two, right? So you have questions in the problem solving format. So you have simplification, you have equations. So the cost of one muffin is $m. The cost of 3 cupcakes is $2m. Write an algebraic expression M for the cost of 5 muffins. So one, straightforward. If one muffin is $m, then what's the cost of 5 muffins? Then it's going to be $5m. That's it. If one muffin is $m, then 5 muffins is just a multiply m by 5, which will be 5m. Part B, 6 cupcakes. Good? So, if you want to determine what's the cost of 6 cupcakes, if 3 cupcakes, and you can do it like this, if 3 cupcakes is equal to $2m, then 1 cupcake is 2m divided by 3. You can use simple proportion, and therefore 6 cupcakes will be 2m divided by 3 times 6, which is 3 to 3 is 1, 3 to 6, 2. 2 by 2m will be 4m. Or you can simply say 3 cupcakes is 2m, then 6 cupcakes will just need to double it. So multiply 2m by 2, which is 4m. Straightforward. You can do this way. So this is, where you have your algebraic expressions to simplification come into play. But then you have part 2. Write an equation in terms of m to represent the following information. The total cost of the 5 muffins and the 6 cupcakes is $31.50. I want you to just write an equation, not to solve it, but just write an equation. So what's the total of 5 muffins? Cost $5m. Plus, that's a total. 6 cupcakes, total cost is $4m. And what is that equal to? $31.50. So that is your equation. So expressions and equations combined. Yeah? Let's look at another. A drinking straw of length 21 centimeters is cut into 3 pieces. The length of the first piece of the straw here, suppose that's a straw, and the length of the straw is 21 centimeters. But this straw is cut into 3 pieces. So let's assume these are the 3 pieces. 3 pieces. So the length of the first piece is x centimeters. The second piece is 3 centimeters shorter than the first. So if it's 3 centimeters shorter than the first, then it's going to be x subtract 3 centimeters. And the third piece is twice as long as the first piece. So if the first piece is x, twice remains to multiply by 2. So that will be 2x centimeters. That's a straw divided into 3 pieces. So they ask us in part 1, state in terms of x the length of each of the 3 pieces. Each of the 3 pieces, straightforward, X will be your first, the second piece, so first piece, X, second piece, X subtract 3, third piece, 2x. Right? So, they want us to write an expression in terms of x to represent the sum of the lengths of the 3 pieces. So, if they want an expression, remember an expression is not an equation. Huh? So, what we're going to do, we want to write an expression to represent the sum of the lengths. X plus x subtract 3 plus 2x. So that's the sum of the lengths, which you can simplify further. This will be x plus x, it's 2x. 2x plus 2x is 4x subtract 3. Then part 3, hence calculate the value of x. In mathematics, anytime you have to solve an unknown quantity, you have to create an equation. So we're going to create an equation here. If this is the length of the straw as an expression in terms of x, this is the length here. It's the same as the length of the straw as a number, 21. These two are the same, they're equal. So what you can do for part 3, you can create an equation here by writing 4x subtract 3 is equal to 21. And you can solve that equation now to find x. So I'm going to remove negative 3 by adding 3 to both sides. So negative 3 plus 3 is 0. I'm going to get 4x is equal to 24. And then I can divide both sides by 4. And therefore x is equal to 6. So that's the value of x. So creating an equation to find the value of x. Okay, let's look at another where we're looking at simplification or expressions and equations. So we have here one past paper questions, getting the practice. $500 tickets were sold for a concert. Of these, X tickets were sold for $6 each, and the remainder of the tickets, so when they sold X for $6, whatever remained from the $500, the cost is $10 each. 1. Write an expression in X for the number of tickets sold at $10 each. Right? So write an expression in X for the number of tickets sold for $10 each. So the number of tickets sold for $10 each will be the remainder. Which will be what? If you sold tickets for X dollars, if you sold X tickets, sorry, for $6, and the remainder, $10 each, then the remainder, of course, for $10 each will be what is left. So, and what is left will be simply 500 minus X. So subtract X tickets from the 500, which will be the remainder represented as 500 minus X. Part B. The total amount of money collected for the sale of the 500 tickets. What is the total amount of money collected? So, it stated X tickets were sold at $6 each. X of them for $6 each. So therefore the cost of the X ticket will be to multiply X by 6. Plus, what is the total amount of money? 500 minus X will be the remaining tickets. And the cost of each of the remaining tickets is $10. So therefore, to find the cost of the remaining tickets, you're going to multiply 500 minus X by 10. So we can simplify that. So we can have the total amount of money collected for the sale of the 500 tickets. So this is 6 by X will be 6X. That's the cost of the X tickets. And the cost of the remainder is the 500 minus X, the remainder by $10, right? So therefore it's going to get what? You're going to get 10 by 500 is 5,000. 10 by negative X is negative 10X. And we can simplify that to become 5,000, and 6X minus 10X will be negative 4X. So that is your total amount of money collected simplified. Then we have part 2. The sum of $4,108 was collected for the sale of the 500 tickets. Calculate the number of tickets sold at $6 each, which is to find X. Because $6 each will be X, right? X tickets. So if this here is the total amount of money collected for the 500 tickets as an expression, and we have the total amount of money collected for the tickets as $4,108, then these two are the same. And we can equate them, we can put them equal to each other. So this is 5,000, subtract 4x is equal to 4,108. Let's solve that equation. So I'm going to remove my x's already on the left. I like to place my x's on the left, or you can put the x on the right. It's up to you. But I'm going to put all numbers on the right. So I'm going to remove 5,000 from the left to the right. So I'm going to subtract 5,000 from both sides. This is 4,108. Subtract 5,000. So my two 5,000s on the left will cancel out, and I have negative 4x is equal to 4,108 subtract 5,000 will give us what? Let's say that quickly. So this is you're going to get negative 892. But then you want to get x by itself, so it means you have to move the negative 4 in front of x. So the opposite of multiplication, that's negative 4 multiplied by x. The opposite of multiplication is division. Negative 4x divided by negative 4. And what I do to one side, I do to the other. Negative 892 divided by negative 4. So my two negative 4's divided into each other to give me 1x. Right? So we determine the number of tickets sold for x. For $6 each, which will be your x. That's 892 positive negative divided by negative is a positive. So that's 892 divided by 4 to give us 223 tickets. We sold for $6 each. Yeah? So this is merging simplification and equations. Right, let's look at inequations or inequalities now. Inequations or inequalities. So, we know an inequality involves what you call an inequality symbol. So you have 4 of them. You have less than. You have less than or equal to. You have greater than. You have greater than or equal to. So let's make sure we can read and convert into inequalities. A farmer plants 2 crops, potatoes and corn, on a 10-hectare piece of land. So if this is a 10-hectare piece of land, he plants potatoes and corn, right? The number of hectares of corn planted must be at least twice the number of hectares of potatoes. Write 2 inequalities to represent the scenario above. So the two inequalities, you start up with the farmer plants 2 crops, potatoes and corn, on a 10-hectare piece of land. So this is a 10-hectare, right, piece of land. Yeah? And what we want to do is create an inequality. Now, if it's a 10-hectare piece of land, in planting the corn and potato, we can't go beyond 10 hectares, right? It's on a 10-hectare piece of land we're planting. So therefore we know that the total number of potatoes and corn planted on this land must be less than or equal to 10 hectares, because we know that the total amount of peas and corn planted can't go beyond 10 hectares. 10 hectares is the max. So as an inequality is going to be less than or equal to 10. Alright? So you can take 10 and then take less than 10. So that's your first inequality. And then it says that the number of hectares of corn planted C must be at least twice. At least means greater than or equal to. Must be at least. When I say at least 2, it means 2 or more. So the number of hectares of corn planted C must be at least greater than or equal to twice the number of hectares of potatoes planted. So this here is, we have 2 inequalities based on information given. So you want to make sure we know inequalities, because as we prepare and continue to prepare for the algebraic component, the revision aspect of things, we're going to get into what we call linear programming, which will involve creating inequalities from conditions given. Alright? So let's look at solving some inequalities. So we have here let's solve the inequality. 4 subtract x is less than or equal to 13. Simple inequality to solve. So how are we going to solve that inequality? So for me to get x by itself, of course I'm going to remove 4. I know with inequalities, always make sure that the unknown quantity is on the left. Make sure that of the inequality symbol. That's not an equal sign. Huh? It's not an equation. It's an inequality or an inequation. So I need to get x on the left. So on the left, I have negative x. So let me make sure negative x is on the left. So to do so, I'm going to remove positive 4 first by subtracting 4 from both sides. So 4 subtract 4 is 0. I'm left with negative x is less than or equal to, yeah? And this will be 9. Yeah? So, what are we going to do? We are going to ensure that to get x by itself, we have to remove that negative sign in front of x. So how are we going to remove that negative sign in front of x? We are going to first make x positive. And how are we going to make x positive? To make x positive, we have to multiply. This is very important with inequalities. Anytime you have to solve the unknown quantity, make sure one is on the left-hand side, but always make sure that unknown quantity is positive. So to make it positive, I'm going to multiply by negative 1. Yeah? And when I multiply by negative 1, look at what's going to happen. Negative x by negative 1 is positive x. Something else will change. The less than or equal to sign will change to greater than or equal to. Something else will change. My positive 9 will change to negative 9. And I've solved the inequality. So remember with inequalities, try to always get the unknown quantity on the left and make sure that unknown quantity is positive. If it is not positive, if it is negative, to make it positive, you multiply by -1, which will make this positive x. You will also change the inequality from less than or equal to greater than or equal to, and it's going to change what is on the right of the inequality, in this case, from +9 to -9. Making sure we know how to solve our inequalities, alright? Let's again see it. Let's solve this simple inequality. Solve for x. We have 2x minus 7 is less than or equal to 3. So let's solve for x. So what are we going to do? Simple inequality. I'm going to remove -7 and I'm going to remove 2. So to remove -7, I'm going to add 7 to both sides. So this will be -7 plus 7 is 0. When I get 2x is less than or equal to 10. And therefore to get x by itself, I divide both sides by 2. So we have 5. X is less than or equal to 5. And part 2 says, if x is a positive integer, list the possible values of x. If it's a positive integer, so remember, integer consists of course, 0 is neutral. 0 is not an integer, it's neutral. But an integer consists of positive and negative numbers. So you want all the values of x that are less than or equal to 5. So you're looking at all the values, all positive integers, less than or equal to 5. So if x is a positive integer, list the possible values of x. The possible values of x, all the possible values of x will be 5, 4, 3, 2, and 1. Not 0, right? 0 is neutral. So 0 is not an integer, considering positive integers and negative integers. And those are our integers, positive integers, that will satisfy the inequality we obtain when we solve this inequality given. Yeah? Alright, so let's look at another inequality. Solve for x when x is a real number. Right? So a real number can be, any number of the number system, positive, negative, fraction. Yeah, that's a real number. So we have 8 subtract x is less than or equal to 5x plus 2. So let's solve this inequality. So we want to get all the letters, all the x's on the left of the inequality symbol. Make sure you have it on the left and all the numbers on the right. And you want to make sure x is positive. So I'm going to remove 5x from the right by subtracting 5x from both sides. And when I simplify both sides, I'm going to get 8 subtract 6x, negative x subtract 5x, it's negative 6x. It's less than or equal to 5x subtract 5x is 0 and that is 2. Let me remove 8 from the left. So I'm going to, this is positive 8, so I'm going to subtract 8 from both sides. So 8 minus 8 is 0. I'm left with negative 6x is less than or equal to negative 6. But remember, we have to make sure x is positive. So what I want to do is to make this negative 6x positive 6x first. Yeah? And then I can make x the subject. So to make this positive 6x, I'm going to multiply by negative 1. So negative 6x by negative 1 will give me positive 6x. But that's not the only thing that's going to change. Less than or equal to will change to greater than or equal to. And that's not the only thing that's going to change. Negative 6 will change to positive 6. Negative 6 by negative 1 is positive 6. So now I can solve for x and make it positive by removing the 6 in front of x, and the opposite of multiplication is what? Division. I divide both sides by 6. And when my two 6's divide into each other to give me 1, x is greater than or equal to 1. And that is solving my inequality. We should know to solve our inequalities. We want to ask people questions, right? And then they ask us, show your solution to A part 1 on the number line. So let's show it on this number line given here. So we're going to show it on the number line. X is greater than or equal to 1. How are we going to show that? At 1, draw a line up, put a circle if it's greater than or equal to or less than or equal to. We shade the circle, which means I'm considering 1 and everything that is greater than it in this case. And if it's greater than, you point your arrow in that direction. So you shade the circle to show that you're considering 1 and of course what's greater than it. And of course you point your arrow in that direction showing all that is greater than or equal to 1. Alright? So that's an answer there. Alright, let's do another quickly. Making sure we're clear on inequalities. Solve the inequality 3 minus 2x is greater than 5. Again, you want to make x is something, make sure all unknowns are on the left of the inequality symbol. So I'm going to remove this positive 3 by subtracting 3 from both sides. So 3 subtract 3 is 0. Left with negative 2x is greater than 5 minus 3 is 2. But remember your x on the left, you want it positive. So let's make this negative 2x positive 2x, so our x when we solve will be positive as the end result. So to make this positive 2x, I'm going to multiply by negative 1. So negative 2x by negative 1 is positive 2x, but that's not the only thing that's going to change. Greater than will change to less than, and that's not the only thing that's going to change. Positive 2 by negative 1 will give me negative 2. And now to make x a subject, where x will be a positive result, I'm going to divide both sides by 2. And therefore my two 2's divide into each other to give me x. I'm going to get x is less than negative 1. Negative 2 divided by 2 is negative 1. Solving our inequality. And again, represent your answer on a number line. X is less than negative 1. So I locate negative 1 on the number line. I put a circle which I leave unshaded because it's less than. Once it's less than or greater than, you have it unshaded. And less than negative 1 means we're going to point our arrow in this direction. So unshaded means that you're not considering negative 1. When it's shaded, it means that you're considering, right? And that would be applicable to less than or equal to or greater than or equal to. If it's a less than or greater than, yes, you're drawing your arrow, your line up from 1, but your circle that is unshaded will indicate that you're not considering negative 1. Alright? Yeah? So you have all that is less than negative 1 should be from negative 2 all the way down. Alright? So, let's do one more inequality. Solve the inequality 12 subtract 4m is less than or equal to 5 subtract 8m. So again we want all unknowns on the left. So I'm going to place all my m's on the left of the inequality symbol. So negative 8m, I'm going to move to the left as positive 8m by doing what? I'm going to add 8m to both sides. The opposite of subtraction is addition, so I add 8m to both sides. Of course, let me simplify both sides. This will be 12. Negative 4m plus 8m is plus 4m. Is less than or equal to negative 8m plus 8m is 0. I'm left with 5. And now let me place 12 on the right by subtracting 12 from both sides. So my two 12s divide into each other. I'm left with 4m. Positive 4m, right, is less than or equal to 5 subtract 12 will be negative 7. And now to make m the subject where m will be a positive result, I divide both sides by 4. So m is less than or equal to negative 1 and 3 over 4. Alright? Making sure we can solve our inequalities. Alright, so this will bring us to the end of today's session. Next week we're going to continue with algebra. So with algebra, we'll be doing algebra for the next 3 weeks. So next week we are going to continue with algebra, and I hope everyone understood what was done today. Remember, we are going to be pushing the work every Saturday straight up until the exam in May, June, and we want to ensure that we can benefit from these sessions that are being done every Saturday. So share, like, share, subscribe to the channel, tell everyone to join, come be a part of it, and let us work towards achieving our distinction in mathematics when we receive our CSEC results. Alright? So that said, have a great evening. See you all next week. Take care.